Patricia, Deniece, Galamgam, our group will be recording the living things in the flight technology. So let's say you bought a model of airplane. How do you set all the hundreds of tiny parts together? First, of course, you will examine the instructions on the box. Then, following the instructions inside the shortcuts of the whole process, putting the model together, and the best way possible is making no mistakes.
Sino pa?
Of course, even lacking any assembly instructions, you can still manage the tasks already processed on a similar model of the airplane. Of course, first is the plane design can serve as an important guide in assembling the later model. In the exact same way, using a flawless design in nature as a model provides shortcuts in designing the technological equipment with the same functions. Aware of this, of course, that the most scientists, the research and development, or the R&D experts, they're the experts that studies the examples of the living things. Before embarking on any of the new designs and imitate the systems and of the design or already exist. Or in other words, let's say they examine the designs that God has created in nature, and then inspired and go on to the new technologies in the present. This approach to the given birth of the new science technology, the biomimetics, which means the imitation of living things in nature. This is a new study of being spoken of more and more often technological circles and is opening up to the important new horizon for mankind. But even before the airplane had been discovered, the flawless design employed by the birds, as bird is one of the living things involved in the flight technology, in order to fly influenced a great many inventors. And as recorded in the the early silent in 19th century, in the movies, some individual activities, they homemade wings onto their arms and hurdle themselves in space, trying to imitate the movement of the birds. And predictably, it did not take them long to realize that the wings alone were not enough to permit them to fly. Since then, mankind had made considerable progress in terms of specific techniques and the research and development. Yet, some are still making claims at least as hollow and irrational as those early inventors. In their view, reptiles burned into the earth, gradually, stage by stage. These imaginary organisms of the gradual evolution has no foundations to support it. Birds possess a totally different structure from a land-dwelling creatures. Their bone and muscle structure, feathers, the aerodynamic wings, and the metabolism, not the slightest and similarity to those of those reptiles. And the alleged gradual evolution model cannot count for even one of their bodily mechanisms. So birds' bodies are specially designed for flight.
My name is Mark Anthony Lumbre, and I will tackle about more on living things. But first, I will ask you a question. Which is the most flawless, efficient flying machine? A Sikorsky helicopter, a Boeing 747 passenger jet, or an F-16 fighter? In this question, I will go with a Boeing 747 passenger jet dahil alam naman natin lahat na mas mabilis ito kumpara sa dalawa. Birds are perfect flying machines. Any vehicle needs to be very light in order to fly. This applies right down to the screws and bolts used to attach the wings. Alam naman natin lahat na yung birds talaga, isa sa mga flawless design na naka-impluensya sa development ng aviation. Have you ever seen a bird explode or fall apart in midair, or a bird lose a wing because the connections to its body have become weakened? In this question, of course, yes. The flawless designs in birds have an enormous influence on the development of aviation. the Wright brothers. The Wright brothers conducted a program of aeronautic research and experimentation that led to the first successful powered airplane in 1903. Yung Wright brothers ay sina Wilbur and Orville Wright. Silang dalawa, may na-invento silang successful flying machine na tinawag nilang Kitty Hawk plane. Kinuha nila yung konsepto sa pakpak ng vulture para magawa nila yung plane na yun. Planes fly much faster than birds, but gives off a lot of heat during flight. In terms of flexibility and maneuverability, birds are far superior to planes. Mas mabilis yung planes kumpara sa mga birds kasi na-invento ito at saka kung merong missile, mas matatamaan talaga yung birds kumpara sa plane kasi naglalabanan sila sa speed. Pero sa flexibility naman, alam naman natin lahat na mas flexible ang bird. May mga nagagawa sila na nakakailag sila or mga iba't ibang movement. Hollow bones is a powerful chest muscles to move those bones, feathers, with properties that enable them to remain in the air. Aerodynamic wings is a metabolism that meets high energy needs. The flap of a flake can repair itself when damaged or even replace itself. Ito yung tinatawag na hollow bones. Sa plane naman, ito yung tinatawag na flap. Yung dalawa na yan yung importante in terms of flight. Kasi kung wala yan, hindi ka makakalipad. Try to tear a feather apart. So ito yung tinatawag na barbicel. Para siyang, kung ikukumpara mo, para siyang sa papel, kapag napigtal, tuloy-tuloy na yung pagkatanggal kapag hindi maayos yung pagkatanggal. Birds are more advanced than planes in a great many other regards. Birds such as the raven and dove can turn somersaults in the air, and hummingbirds can remain suspended in flight. They can change their minds in flight and suddenly alight on a branch. No airplane can perform such maneuvers. Yung birds, mas malaki talaga yung factor niya kumpara sa plane. Kasi yung bird, yung neck niya, kayang abutin from beak to any part of the body. Isa na ring factor dito yung feather niya. Yung feather niya, isa to sa mga best component in terms of flight. Kasi kung walang pakpak, syempre walang lipad. The Cobra maneuver performed by Russian pilot Viktor Pugachev in his Su-27 jet has gone down in the history of aviation. Yung na-invento rin ni Viktor Pugachev na Su-27 jet, naitala rin ito sa history ng aviation. As you can see, makita mo sa beak ng jet, yung tinatawag na Concorde. Yung Concorde, ito yung gumagawa para maitaas at mababa yung movement ng plane. Nakuha rin yung konsepto nito sa dolphin. Yung dolphin kasi from water nag-up and down din. Kaya nakuha yung konsepto nito sa dolphin. Birds' bodies are specially designed for flight. A giant at a bird's neck is sufficient to illustrate this. Marami ring factor yung na-contribute nito. Yung flamingo and yung giraffe in terms of plane. Marami ring nakuha na factor, lalo na yung one na X factor nila, yung neck nila.
Welcome, my name is Dana Andres Cuerdo, and I will be talking about living things and flight technology. But first, we need to define flight and technology. So, flight, it is an act of passing through air by the use of wings. So, to be exact, flight means using air pressure to produce lift, and we use the airfoil as a means to fly. I will define the airfoil later. But first, we need to define technology. So, technology deals with interrelation with life, environment, and society. It can be engineering and applied science. In other words, technology is the application of knowledge in science, engineering that can be embedded in machines and computers. So, therefore, we can conclude that the definition of flight technology is the application of knowledge about physics, science, and biology, applying it in a machine. But we need to know what makes an object fly. So, there are three factors. It is the force, airfoil, and wing loading. So, forces, there are the thrust, or the forward force, the drag, or the opposing force, weight or gravitation, or the downward force, and the lift and the upward force. Airfoil and wing loading will be discussed in the next slide. So, airfoil. Airfoil is a curved structure designed to stabilize most aircraft machines. It is in a form of wing or fins and etc. So, here, in this picture, this is the airfoil. And as you can see, these are positive pressure area going on the bottom of the airfoil. Therefore, it creates a lift upward. So next is the wing loading. A wing loading is a measurement that relates the mass of an aircraft or bird to the total wing area. I can best explain this by relating high wing loading versus low wing loading. So, what if you have a high wing loading? It means that you have a smaller wing for a given weight. It has a higher stall speed, longer takeoff and landing distance, poorer climb performance, poor maneuvering performance, or turning, and it has reduced skin friction drag, meaning you have a smooth ride because you have a wing insensitive to gas and you have a reduced weight. Now, what if you have low wing loading? It means that it has a larger wing for a given weight, lower stall speed, shorter takeoff and landing distance, better climb performance, better maneuvering performance, higher skin friction drag, meaning you will have a bumpy ride and the wing is sensitive to gas, and you have a heavier airplane. So, the example of high wing loading are the airplanes. As you all know, airplanes have a longer takeoff and landing distance. It has a poor climb performance and poor maneuvering since you only need to go from one destination to another destination. Unlike the low wing loading, the example of low wing loading are the bomber jets, wherein they have a better climb performance and better maneuvering, of course, because they are used for war. And they have a higher skin friction drag. It means it's wing sensitive to gas because they don't need their safety. And for the airplanes, it has a smooth ride, meaning the wing is insensitive to gas, of course, for the safety of the passengers. So we will talk about the types of flight. There are the buoyant flight, wherein humans create lighter air vehicles that float to the ground due to their buoyancy in air. But what is buoyancy? Buoyancy is the upward force because air displacement is equal or greater than the force of gravity. As we all know, the force of gravity is a downward force, and humans create a air vehicle that is equal or greater to the force of gravity. Therefore, that upward force, the lift caused by the air vehicle, opposes the force of gravity. Therefore, it is stabilized in that area. So, next is the aerodynamic flight. This aircraft produces lift and thrust to the propeller in order to fly or glide. As I have stated before, there are four forces acting on an object. Those are the thrust, drag, lift, weight. Of course, in aerodynamic flight, this aircraft produces lift, and so the propeller produces thrust, the wing causes drag, and the lift is also caused by propeller, and of course, the weight is caused by the gravitation force. Next is the mechanical flight. It is the use of machine to fly. So there are two factors to consider. The one is the power flight, the use of propellers. So there are two factors to consider. One is the powered flight, the use of propellers. The other one is unpowered flight, or also called gliding. So next is the supersonic flight. The other type of flight is the supersonic flight. Supersonic flight is traveling faster than the speed of sound. Whereas supersonic flight uses compressible flow because of compression associated with shock wave. It is created by an object traveling faster than sound. So last is the hypersonic flight. Very high-speed lift can be seen in space shuttle. Hypersonic flight compresses the air and the heat generated caused by it, and it causes chemical change to the air. So, hypersonic flight is like jet, wherein the jet sucks all the nearby air in its surroundings, and because of the heat generated, it causes chemical change to air, and it creates a strong force. It creates a strong force. That's all. Thank you for watching.
Hi, my name is Nicole Lentejas, and I'm here to report about living things in flight technology. First of all, development of flight technology. 20th century development in flight technology. Wilbur and Orville Wright made 4 controlled sustained flights in a powered heavier-than-air vehicle. Never claimed to be the first to fly, but the main claim of the Wright brothers was that they were the first to design and build a flying craft that gave the pilot adequate control while in the air. The unique feature of the Wright brothers aircraft was the ability to roll the wings left to right, to pitch the nose up or down, and to yaw the nose from side to side. The pilot must have control of all 3 dimensions. The 3 dimensions are roll, pitch, and the yaw to navigate the plane. The second is Henry Fabry and Glenn Curtiss, credited for making the first seaplane known as hydroavion flight. It had a 50 horsepower gnome rotary engine and was mounted on lightweight hollow wooden floats. It flew only short distances, however, and just 2 months later, it was wrecked when it took a sudden nosedive into the Mediterranean. The first practical seaplane was constructed and flown by Curtiss in 1911. And also in that year, Curtiss's flying boat made the first transatlantic crossing with no stops. And for that, Curtiss became one of the most successful American aircraft builders following the invention of the airplane. Anthony Fokker, or Anthony Hermann Fokker, produced numerous planes for Germany, including the Fokker Heidelberg fighter, which featured a machine gun that could fire through a moving propeller without hitting the blades. In 1920s, Fokker established an aircraft company in New Jersey and set about designing aircraft for fledgling U.S. commercial aviation industry. The first nonstop across the United States was made in Fokker T-2 in 1923. Meanwhile, Elmer Sperry introduced a type of gyrocompass that was later used in ship plotting system. Important planes of the interwar period was Boeing's 247, introduced in 1933, and was considered to be the first modeling airliner. Thank you for listening.
Hi, this is Camille Carillo, and I'm here to report about flight technology in relation to living things. But first, let's have the definition of biomimetics. Biomimetics is from the Greek words bios means life and mimesis means imitation. So basically, biomimetics or biomimicry is the imitation of the models, systems, and elements of nature for the purpose of solving human problems. Humans have looked at nature for answers to problems throughout their existence. As you have all noticed, most of our aircraft have all one similarities. They all have the wing-like shape on their sides, and this is called the airfoil or aerofoil. The wings of the plane is very important part of the plane's flight. The shape of birds' wings is the determining factor in their ability to fly. Wings of fast-flying birds like falcon, hawk, and swallow are long, narrow, pointed features that have served as a guide to flight engineers. The flawless design in birds have an enormous influence on the development of aerodynamics. Even the first airplane, the Wright brothers model, after a vulture's wing, the straight outstretched, motionless wings of birds like condor, hawk, and vulture which swoop and glide. Engineers constantly search for ways to improve aircraft. Technology and nature inspires the greatest innovation. One major problem in the current aircraft technology is the engine produces a very loud sound. to reduce the noise created by the aircraft while keeping takeoff energy efficient. So scientists started to study about owls. Owls silently glide at night to catch their prey unawares, then suddenly swoop down. According to the findings of researchers at NASA, an owl's flight feathers, unlike most birds, the flight feathers of whose have a sharp, clean edge, have soft fringes that decrease the turbulence. In terms of flexibility and maneuverability, birds are far superior to the planes. A bird's neck allows its beak to reach any part of the body so that the bird is easily able to maintain its feathers, the most important component of its flight. Birds are very intriguing creatures. For one, they can fly without any aid from any other things than their own. They have hollow bones, powerful chest muscles to move those bones, feathers with properties that enable them to remain in the air. All these features which clearly shows their extraordinary abilities in the air. Birds are more advanced than planes in great many other aspects, like how bird doesn't overheat, or they don't make very loud noise when flying. So that's all.
Other living things related to flight technology. The first one is Loligo vulgaris, or European squid. European squid employs a propellant force similar to the principle used by jet engines. So this is the illustration of a squid's body. A squid's body contains two open spaces like pockets, which is called the mantle. Water taken in from them is drawn into a powerful elastic bag of contracting muscles. In this bag is a backward-pointing nozzle. The muscles contract, known as the siphon or water jet, expelling water out of that nozzle at high speed. This animal can reach speed up to 32 kilometers per hour. So, the second one is the cephalopods. Cephalopods are the most intelligent, most mobile, and the largest of all mollusks. They give remarkable display in diversity in size and lifestyle with adaptation for predation, locomotion, and communications. Examples are cuttlefish, nautilus, and squidward. There are some examples with the same principle in jet planes and mollusk. So the first one is scallop. Scallop, scallop when threatened by a starfish, the scallop suddenly closes the two halves of its shells. It thus expels a quantity of water in such a way as to set up jet propulsion and forces itself forward. Same principle in terms of Newton's third law of motion. So the other one is known as the squirting cucumber. The squirting cucumber disperses its fruit seeds in a sudden explosion. As the fruit ripens, it fills with the slimy juice, which gradually creates pressure through the build-up of internal pressure. It then propels its seeds with an initial velocity of 56 kilometers per hour.